Slide. So let's talk about chatting in a nutshell. Okay. So let's say in this slide, you can see there are like multiple different type of clients. You have desktop, you have a smartphone, and you have tablet. But let's say HTTP is already supported because they support browser. Now the language or the platform they are using, maybe let's say native or Android and everything. Let's say all those are supported, then all can support WebSocket connection as well. So let's say you also have a server and all those are actually connected with the same server. Okay. So if you had to actually think about chatting in a nutshell, what happens, like multiple clients are connected to a server. Okay, and server actually has three connections. Okay, but it also have to identify, basically in your application you have to keep a mapping or something, like maybe in a third party or in memory, right? You can maintain a connection saying that these are my connections and these are the clients. Okay, so you have to keep a way to identify which connection maps to which client, right? If you have that sort of a map, so how exactly chatting will work? Let's say desktop says, let's say desktop is one of the clients. It says that I want to send a chat message to smartphone user, right? The second user. So that desktop will send a message to server, okay, saying that I want to send it to smartphone user and this is my connection. Okay. So server will identify that whenever you say smartphone, it will find from its map what's the connection I use for connecting with smartphones. It will find that connection ID or connection object, right? And it will use that text message and it will pass it over to the second connection it has with the smartphone. So if you get a response or a message from desktop to the server, server can send it back to the smartphones. That's how exactly your chatting works, right? You basically you pass on messages from one user to another. Okay, question is, how is authentication authorization managed in web sockets, right? So I think I'll not go into much detail in authentication authorization, but at a high level, you can think about, right? Let's say if you're using WhatsApp, there's a registration process, there's a tokens actually distributed, right? That's how your server identifies that you are the right user. Okay. Then it also maintains sort of allowed listing or a block listing and everything to see whether you can send messages to another client. And if you're allowed, then actually it figures out like what's the connection for that smartphone or the second user, and then sends out the response. So there are multiple steps used by multiple companies. Some use encryption also to ensure that the data is not actually read in between. So I think I'll not go into much detail, but this is the I would say small at high level things people use for authentication and authorization across the WebSocket. But WebSocket by like for its own definition, it does not support, I think, any sort of authentication, I would say. I think whenever you establish the HTTP connection itself, it does allow, I think, on default, like if you know the IP and if you know the API, you can send a connection with it. Server can close it anytime, so it can have its custom authorization or authentication mechanism to identify whether it's the right client. If it is not a right client, they can close the connection. Right? That's what the protocol itself supports. Okay, so now it's time for WebSocket demo. I think somebody has also asked the question. Okay, so simply search for this Expertifie WebSocket. Is actually a GitHub repository. I think Anil has already sent it out. So if you open it, it's actually a very small set of code you can see, and it has a README also that you can use. So it basically has one README and then two files. There's one server.go and websocket.html. So you can just get simply, if you have already CLI and everything established, you can use this. Otherwise, simply go and download a zip, right? And open it in your local. Now coming to steps. So what I'll it has already mentioned all the steps. What you'll have to do is like install Go. Okay. So if people have already installed it, no issue, just wait for some time. And once you have already done the code, run these commands actually. Go in it, then go get and go run. So basically, I'll run you through what exactly this code is supposed to do. But meanwhile, just set this up. Maybe we can take some 5-10 minutes to allow everyone to set it up. Okay. Meanwhile, I think there's a question: group chat, how server manager to send multiple clients at the same time. Okay, I think group chatting. Let's take it towards the end. I think first I want to uh, cover actually the basic concepts, then WebSockets, and then we'll cover first. Let's not jump into group chatting right away. I think let's first understand one-to-one how scaling everything works, and then we'll see how group messaging works. Okay, then if the connection is open in WebSocket between server and client, is there any threat of interception? Okay, so again, like see interception security, what I'll say, like it's actually just like any other protocol, right? Over a wire, if you have a socket or anything, that can always happen. Yeah, I think Anil has already mentioned, like sniffing and everything can always happen if you are using a network, right? It's not an isolated network, then people can set their own device and everything. That is where the security mechanisms come in, right? To keep encryptions and everything. So even though you have a router or sniffing device, it can, if you use encryption, it can still understand your IP addresses and everything, but it will never understand your message, right? What exactly you have sent. So that's where encryption comes in handy. Okay. So is everybody able to see the terminal that I have opened?
Yep. Yeah, we can.
All right. So what I'm doing, I'm using Windows laptop. So I'll just set the right location for it, for the project. And we'll go into the parent directory and then run the commands. Okay, so I've already have Go installed, so I'll not go install it again. So if you see this parent ls, there's another file go.mod created here, and if I do a cat for this, basically it's showing that I created a module for it, and the Go language that I'm using is Go 1.17. I'll just run the second command to pull my dependency. This one takes some time. Folks can give it a try, maybe with Go language 1.17 version, just for the demo. I'm not sure. I think the new upgrades might have a different settings. Okay, so basically what it has done, like pulled me this version of WebSocket into my local. Now I think I'll just do a simple ls to see what all different files I have. So it has created something called go.sum, and we can see what this file has. first we'll see go.mod. So if you see this, earlier it was this module, then it has added a dependency as well. And then we'll see if something is there in go.sum. So it has like a dependency pull and I think some details about GitHub. Okay, so final steps to run the server. To go run server.go. Okay, I think server is already starting up. I'll just start this locally. So let me just do a quick code walkthrough what it exactly does. Okay, so I just go to server.go. Just switch this share screen share. Are you able to see this GitHub page now?
Yes, yes.
Okay. So I'll just quickly walk you through what exactly this server is doing. Okay. So I started very basic piece what it's doing. So it's starting. I think these are the methods. If you see, I think at least I'm hoping everybody is actually able to see this page and the code. So if you see these, here are some helper methods. There are some variables I've defined, and these are basically imports. Coming to the main section of the code, so there's a main method. Again, this piece is a handler. Okay, so how you handle it's again a method defined, and this is the piece which starts up the server. So you have, I just have printed starting to indicate that my server is starting. And in Golang, there's a very small code to start a server. That's why I think preferred Golang for them. It basically what it does that starting a HTTP server at port 8080. Okay, that's all it needs to start up a server. Now, what should the server do? Okay, so that's where we define the handlers or controller for this. Okay? So what it says that if you come to root directory, it had to respond back the Websocket.html. So if you remember in the previous thing, right? This Websocket, we have a file called Websocket.html. So what it will do is like if you make a request to the root directory, it will send out this HTML page to you. That's all it does when you make a request to root directory. So now let's look at WebSocket HTML, what it does. Okay. So coming to WebSocket HTML, so it has HTML code and JS code. Okay. So HTML is just to represent how exactly things will look like. I'll just cover the JS part of it. Okay. So what JS part is doing, this is the script part of it. So it's taking some variables, getting the input output. Now it's creating a WebSocket connection. Okay. Over this link, WS, that's represent WebSocket protocol. Localhost is 8080 and the to-do is a / path for it. So basically then define some variables and sending value will in demo, I think these things will get clarify what things to do. But major thing that wanted to demonstrate that's actually going to a path called to-do. Okay. And starting to create a WebSocket connection. So if you try to match this with one of the previous slides, we had a first HTTP connection established. Okay, so browser is making a request to the root directory, and then service is returning back to your HTML page. Right now, in HTML, you have a script basically says that create a WebSocket connection with this localhost 8080 and then to-do path. Okay, so let me go back to the server code. So here you have a method to do, right? This is the path and you have a function defined to work on that. Okay. So what this function is doing, basically it's making an upgrade. Okay, so you have requested actually for a to-do path and using this WebSocket protocol. So what it does is upgrades this. So in Golang, there's again API, or I should call it. So you have already a WebSocket, HTML connection, which is represented by your W and R variable, and it's making a call to your library, the Gorilla library, to upgrade this connection. So the connection object that you get now is a WebSocket connection. Now what I'm doing is adding this to a pool and then taking some nice, basically doing some stuff over it. I won't go much into detail. Just one line here that if you see this, I'm iterating over the pool of connection and sending out some message, right? So if you look at here, I'm actually also maintaining a pool of variables. A variable called pool, which basically is an array of WebSocket connections. So think about in this, like let me summarize. Your server has a connection pool. Okay. So whenever there's a connection request, it will maintain all those connection into a pool, and it does some stuff, some input manipulation and everything, and sends it this information over all the connection it has available. So I'll jump to the demo. I think that will give everybody more clarity. So let me open this up, localhost 88. So when I requested to this root directory, give me this HTML, and HTML basically has two things: add tasks and done tasks. It's basically a to-do sort of example. Right? So what it does basically, whenever I do take this instruction, let's say add maybe T is one of my tasks. Whenever I send it, it sends me back, the server basically sends back all the to-dos that you have in this list. Let's add a couple of them. Okay, so let's add milk. So you can see this. As soon as I send this detail, the server is sending me milk and tea both. Okay, so it's also maintaining this. So let me, if I say that tea is now done, and you'll see that next setup is milk. Now I have only demonstrated you over a single connection, right? Now let's look how exactly it's over multiple connection, right? So let me just open my screen to let me know if folks can see.
Yeah, we are seeing split screen.
Yeah, split screen. Okay. Yeah. So very quick. Right. So if you can see, there are two clients. So what I have done, I have created two clients connection with my server and backend, and the second client will also get all this information. So if you remember the code that I had, so right, I'm sending some information over all the connections, right? So this is the code. Is that okay? So I'm iterating over all the pool connection and sending over some information. So we'll look at that. So let's add some to-do things. Okay. So maybe let's say to-do is walk. So as soon as I have added walk, you can see I have got this detail from server milk and walk, but not just to this client. I've also got through this client, but this client hasn't requested it. Okay. So basically, it's sort of a demo. Let's say if you have multiple connections and all the connections are stored by your server always identifies that what connection everything can contain and create a mapping or cache anything on its own side to identify which client is using which connection. And as soon as it has some information, it wants to send it back to the client, it can do so. So if I just done well, right? So if as soon as I send this, I got this walk, and you can see this is also a label here. I can create as many as client I want here, and all this information will be shared with every client. This is how my WebSocket or server is behaving. That's for the demo purpose. But what I want to demonstrate that when as soon as you're connected, right? It's a common connection. Server can send it anytime, client can send anytime, and server can manipulate all this information that you're sending, can use the existing connections to send over anything that it wants. Okay. That I think I've already demonstrated. If anybody has any question, want to ask, feel free.
Yeah, I want to add a small point here. So that firstly, this is awesome. What my friend has done here is he has not just explained you guys WebSocket, he has actually gone ahead and implemented it. And so what the real essence here was that just like the main intention, what we are trying to communicate here is that a WebSocket communication can be done from client to server and server to client, right? So far, like generally people have a perception that a client sends a message and server replies back. But what Raghavendra has just shown here is that when in his second split screen, when he's doing add water or add milk, then he's getting reply in the first split screen as well, where the client has not even requested a get call. So this is the real essence of WebSocket, that server can push replies back to all clients, broadcast it, or so in case of WhatsApp, he will cover how it actually does. But this is the main funda of WebSocket and how it handles bidirectional messages. So just to add a few sentences over this demo, and thanks a lot for this great demo. Yeah, proceed ahead.
Thanks.
One question, Rahul. So, like every time you are doing a split screen and making connection with the server, so that will be a new connection ID will be created for every time, or like because we have the same source, I mean same
Yeah,
client.
so how, I think maybe I'll just get one liner sort of about how browsers work, right? So in browsers, every tab is a different process. Okay. So process basically, it's actually a different client. I can use a different browser that it's actually any tab that you use is actually a new request itself. So in the new tab, what I'm doing, I'm just making a request to the root directory of it, right? And it will connect to the service. So maybe I can inspect this. Give me 1 second. Network. Okay. Let me just enter some details. I'm just making a request to root directory. We can see what all requests it makes. Okay. So if you see this one, I'm making a request to the root directory. I got some response. The response is my HTML page, right? I can look at raw. This is my HTML page. These are the headers requests that I got. Okay. Next one is my WebSocket connection. Right. This is my JS coming into play. So it's making a request 1.0 switching protocols. This is how you upgrade a connection behind the scene, but in library is simply object creation, as you can see in the JS code. It's already present here. You can take a look. Now, if you see here, I think it's making upgrade request. In the response, you can, I think response is nothing. This connection is actually successful, and next step is just, I think, this simply adding it. Maybe I can add some, let's say, task 1 and send it across. Now it's actually, I think, going over the WebSocket connection. That's why it's not showing up here. But every request that you are using as a tab, it's actually a new request connection. Yeah. So I just, as soon as I added tasks, if I go to other tabs, you can see task 1 is added, task 1 is added here, task 1 is added here along with work. So it's a new connection that you can first sure check. I think this time, first time I'm actually inspecting a WebSocket connection. HTTP, I think it's demonstrating well, but not for WebSocket. But I think that the one thing that you can be sure that every tab is a new process, every new connection.
So yeah, one more thing here. Rahul, can you click on the second to do 101 in your network tab only? No, go back to the network. Yeah, click on this. So this, if you are seeing in response header, connection equal to upgrade, right? So this means that the response is here is coming from your WebSocket. This upgrade is the key header, which actually upgrades a TCP connection to a WebSocket. And yeah, that's one point, one of the important point that you guys should know. And if you can just click on the response or request tab here, Rahul. Yeah, just see here that request may we are sending the body, so it's not coming, but you can see that all the, and now make a call from another on your split screen. First screen, make a call to send something like send task 2, like add task 2, and you will see some response here. add, I think your command. Yeah, just do a send.
Okay.
Yeah. So this is the great thing about. So how many of you guys have seen this before? Like, have you seen that a client is sending request to server and replies coming back to another client who has not even sent a connection? So this actually explains that double duplex connection has been set from each of his browser windows to one single entity, which is server. All requests that the server is getting is just writing it somewhere, storing it somewhere, and just spitting it out to every single client. So without even sending a request in his split tab 2, response is coming. You are seeing that's the great thing about WebSocket. So yeah, go ahead. Great demo. Now we can proceed, I think.
I think somebody has mentioned this getting error Websocket. So I think this is a CR, this cross domain issue that you are getting. Maybe we are using different thing, where maybe 127.0.0.1 for somewhere and localhost somewhere. Make sure that you are using the same IP name.
To be honest, even I wasn't able to set it up, guys. So take it easy. He is quite a pro in this. So it's okay. Let's just watch the demo, understand the concept, and we can try it out later. Thank you. Yeah, continue.
All right. So I just close all these tabs. Let's go back. Yeah, I think this is available. Code I don't think will change much. Whatever Go version that you have set it up, you can see for what the steps you require for running this server. So you can do it offline as well. Coming back to the presentation. Okay. So let me just go to next slide. So what we want to build here, right? So I think this is why you guys mainly joined here. So build a WhatsApp like feature. So first I covered, I think, network protocols mostly. Then we came to WebSocket and how WebSocket is, I wouldn't say better than HTTP, but there are use cases where WebSocket actually helps much better than HTTP. I think somebody has mentioned, do we need to learn Golang? No, you don't need to learn. So it's a protocol, right? Similar to HTTP. So HTTP is supported in all the languages, in your JS, in your Java, Python, everything. So any language that you use, just search for how WebSocket is supported in that language, and you should be okay. Don't need to learn, go for it. Yeah, these are language independent. These are protocols defined. So I think that's the main definition of protocol, right? Protocol only tells you how, like what to do, right? How to do is independent. So how to do is actually implemented by each language separately. Okay, so let's come to this, right? How do you build a service, WhatsApp-like service? Okay, so in MVP, I have at least just looking at the time, I think we want to cover these pieces. One-to-one text messaging, then single tick, double tick, and blue tick. Right. So single tick is basically you have sent. Double tick is received by your sender or like whoever you're trying to send to, and blue tick is it's been read. Right. Next is online presence. So our last thing. Then local storage and release of messages, and I'm keeping most of the things out of scope as of now. I think it will take us time, a lot of time to walk us through all this MVP. And if we get time, we'll try to cover other features. So let's quickly jump on it. I'll use draw.io to cover most of the things. And I think we can ask questions and everything just like before. Okay, so I think first we'll try to cover one-to-one text messaging and how to implement it. Okay, so this is my diagram or sort of page that I have. Okay, so let me start. Let's say you have two clients. Let's take two clients as minimum to demonstrate this. And you have this one, let's say call client A, and client B, right? Now, looking at how WhatsApp works, right? So, okay, that means, let's say you have web cloud, right? And your so how these devices are connected, basically, this is called it has to be connected with some server first. Okay, so let's call this gateway 1. Please pardon my the handwriting. If anybody has any questions, feel free to ask. I'm trying my best to write it here. Okay, so let's say there are two gateways, and client A is connected with gateway 1, and client B is connected with gateway 2. So what kind of sort of connection this has to be? WebSocket, right? Because HTTP does not support from a service. Let's say if we had to send some message, how it will be? A will send message to its own gateway, okay? And somehow the gateway which is connected with client B, it has to send the message back to B, right? So basically it's an action which server has to perform, and it cannot do unless it has a WebSocket connection. So all the connections that you have here is the WebSocket. So let's say this is WebSocket connection 1, and this is WebSocket connection 2. Okay. So A will send, basically it will be like a message, right, over the connection. So as we mentioned, WebSocket supports two sort of messaging. One is text, and second one is binary. Okay, so binary generally, so it's used only when you're sending some media and all, but let's look at text. Okay, so it's a connection, a symbol connection already established. So how do you ensure that you're sending a message? So you have to define some ways between which is totally understandable by your client A, client B, as well as all the gateways and everything that comes behind. Okay. So I'm just keeping at a high level how exactly we'll achieve it, and then we'll come to different components and everything is required. So let's define how exactly client A is supposed to send. Okay, so it's a connection. It's already established connection. You don't know. It's similar to HTTP. Does not support APIs, pass methods, and everything. It's a simple connection. You can send everything over. So let's say for sending. So for sending, you have to define some mechanisms so that your client A can send the information and your gateway can also understand. Okay, so it can send information like this. I'm just creating a standard format. We can change it along the line if requirements increase. So it have to send like who is the sender. Okay. Then receiver. Okay, then what's the action? I think let's assume that it has to make multiple actions. I think as per requirement, action will definitely come in, and then you'll have a text. So we are only covering text for now. I think media and everything will be advanced. So how it will look like? So if A wants to send some information to B, it will look like A is sending some text, A comma B comma, then send. Send is a constant sort of. Okay. And then it will say send some text. Let's say text name is hello. Okay. So this is how your message over the WebSocket will look like. Okay, it's not an HTTP call, so you don't have APIs, you don't have methods. You have to communicate whatever you want to do over the same connection itself, right? So this format also needs to be understood by your servers, gateways, and everything. So whenever you send this information to your gateway will just simply get a string which is connection of all. So A comma B comma send comma hello, right? Now it has to understand which is the sender, which is the receiver, which was the action I'm taking, and what exactly I have to do. Right? So that's how your protocol, it's basically, you can say that it's a protocol you're defining for sending over your WebSocket protocol. Now, let's think about it, right? If A and B both were connected to the same gateway, right? Similar to what I had put in a single slide, right? So gateway, one will obviously know that which connection I can use to send information to B, right? But when we scale it up, gateway one does not know anything about client B. Okay, it only knows that client A I have. So let's say gateway A1 has multiple clients. Okay, so sorry. So basically, it will have a table sort of information here. Okay. So let's say A is maybe WebSocket 1. That's the connection. And what's the copy which gateway 2 will maintain? That it will say that I have client B over WebSocket connection 2. Okay. So these all information every gateway will maintain, right? That's all the gateway, the single gateway knows. But let's say I have to send information from client A to B. There has to be some way to identify that B is connected to gateway 2 and pass on this message from gateway 1 to gateway 2, right? So I'm just creating, like, let's say I need some mechanism that I can send this information from gateway 1 to 2, right? And then gateway 2 can send it back to B. So that's where my whole end-to-end flow for sending a message will be complete, right? Any questions so far? Anybody has any question what I've covered so far? I haven't gone into deep how exactly we'll do this, but if you are able to achieve this gateway 1 to gateway 2, if you are able to send that information somehow, your work is done. So I'm not seeing any questions. I'll move forward. So how?
Rahul, one question. We are doing a additional hop, right? I mean, message is traveling from A1 to gateway 1 and then from gateway 1 to gateway 2. So this is additional hop that we are doing, right?
Correct. Yes.
So, okay.
So in WhatsApp, let's say if you're using WhatsApp or Telegram, it's not a single hop from A to B, right? Otherwise, it will be a peer-to-peer connection. So with WhatsApp, Telegram, any application that you use, and Facebook chat, it's actually through a server-based model and does not say that it's a single hop. It's multi-hop, and you connect to a single box, a single gateway, right? But what it does behind the scenes, it's up to the application, right? And they ensure that it's a real time, but they don't say that it's actually totally real time. It's actually on the traffic load, how different services they have, right? What's the network load and everything, and post them. So if you might have seen that WhatsApp is stuck over Diwali or New Year, right? When multiple people are actually sending messages. So if it was like a single hop, you'll not see that issue. It's a multiple hop. That's how the whole entire service is actually maintained.
Okay. Sure.
And that's how you scale up actually any application.
I have one question. Like this is just like TCP connection, right? Router to router to router. Like
No.
multiple routers will be there in gateway.
Okay. So what I have actually represented in this is actually, I would say, OSI level 4 and above. Okay. So it can be like over the same WebSocket connection, there are multiple routers in between. Okay. So I'm not going to that physical layer, right? Physical layers. There could be multiple routers here. There could be multiple IP devices in between.
Got it. And same between gateway 1 and gateway 2.
Yes, there could be multiple devices in it. This is just a representation at level 4 and above, OSI model level 4. Level 4 is basically TCP. Then you talk about WebSocket and your application layer. There could be multiple devices if you look at, because even your laptop is connected through a router, then goes to some network provider, then multiple routers are actually involved. So let's ignore that for now. So all your network level 4 and below, there could be multiple devices which are actually over that connection. And as of now, this connection I'm not established. I'm just for a demo purpose. I'm saying that if there's a way I could send information from gateway 1 to gateway 2, then your work is done for sending the text message. Right? That's how you can look at this. So that's how you design it. Now, you have defined all this. So what thing that you have to achieve is like, how do I send this information from gateway 1 to 2? That's all as of now you need to achieve to ensure that your message gets delivered, right? So I'll just resume here. If anybody has any question, do ask right away.
Yeah, I have one question, Rahul.
Uh-huh.
Maybe you can explain in a little more detail. Why are we even using WebSockets for this purpose? Why can't a trivial, let's say 2 clients are there, one client sends a request to server, server reads the request and directly redirects it to B, right? Why are we even using WebSockets? Can you explain that?
When you say redirect, what is actually your suggesting there with the redirect?
Redirect as in the server stores the request and then the client can keep polling the server to get a response, and the server can send the response.
Right.
So yeah.
So I think let me just go back to, I think, one of the demo that I had presented, right? So as you can see, let's say in this diagram, client A, this is your client A, the yellow guy, right? And it's actually trying to send message to client B. Okay. So if you have HTTP connection, if let's say it has sent it to HTTP server, so the client B basically will have to poll every time actually to on, let's say, multiple intervals to see, do I have messages, do I have messages, do I have messages, right? And
this is because server can't send a response to client without them requesting over a HTTP protocol, right?
Correct, correct.
Okay.
And you have a WebSocket connection established. As soon as this, basically this WebSocket is more like event driven. Okay, so it avoids any resource loss, right? So in this connection, when you have HTTP, the server and the client both are doing a lot of work to do sort of polling actually, right? When you have maintained a connection between WebSocket server and the client B, it's a connection established, and as soon as server gets that message, it sends back to client B. And that's what exactly WebSocket helps. Whenever you have an action where server needs, any server or gateway needs to send an information to some client, it's actually from server to client direction, right? That's not supported in HTTP unless somebody polls for it. So this is more like, let's say client A sends out this information to WebSocket server, and server got an event that I have received a message. It passes that message. It figures out that this message is meant for client B, and I already have a connection with client B. I can send over this message to client B.
Yep.
What about long polling? Can we use it inside of WebSocket? Yeah, so long polling is a different concept which has actually come up with, I would say, upgrades of HTTP, right? But I think actually you can definitely use it. That's one way of it. But I think WebSocket as of now are actually, I would say, like dominant sort of technology that we have for maintaining a single connection. Even the long polling has a timeout. So over a period of time, you can actually, you have to terminate that connection and then figure out what you have to reestablish the connection. I think we'll not cover long polling and all. I think WebSocket is one way of long polling, but I would request everybody to just search what is actually long polling is on web. The HTTP 2 that we have, I think it supports long polling, but as of now, I think the industry hasn't accepted much on HTTP 2. WebSocket is actually much simpler or adopted way at this point to establish a better connection between client, long lasting connection between client and server.
And great, thanks for clarifying. One more question. So what are these gateways? Can you clarify? Are these, what entities are these? Are these servers? Are these compute machines, or what are these gateways?
So gateways, you can think of those as load balancers for now. Okay. So how load balance? Basically, I think maybe I can take that as a different section. So let me. So let's think about this. Okay. So let's say you have a device, right? Let's say you have. Starting. So let's say there's a device in US, okay, and there's a device in India. Then there's a device in, let's say, different states of India, MP, and then And then let's say you have for Telangana, right? So how basically first level of load balancing, which nowadays services actually do or application do, is like DNS level load balancing. Okay. So what it does, like let's say in your application, basically you have a device, okay? So what it will in the device or the Android software or iOS software that you have, it will have a single URL, okay, saying that connect to this endpoint for getting messages or sending messages, right? So what it will be like, it will be simple, some let's say whatsapp.com, right? And some path or something. Let's say for establishing the first HTTP connection, then updating into WebSocket. So it will have this DNS or what we call basically this text, right? Similar to google.com and everything. So whenever you do a DNS also is a sort of a distributed service. It basically will have at worldwide level. Then it has maybe continent level. Then you have at country level. Okay. And then maybe you can have again at more granular level. So what applications do, like they will set up some DNS servers. So whenever let's say you first make a request for getting the IP, because you cannot make a connection just over whatsapp.com. It has to get some IP to make a connection or HTTP call. Okay. So basically you make call to worldwide DNS server. Then it will redirect you to some country or content-based redirect DNS server, and from there you will get an IP back to it. Okay. So when you receive the IP and you have the port, then you start your HTTP connection or WebSockets connection for upgrade. Yeah. So what DNS servers generally do, like if you make a call, let's say for WhatsApp, I made a request to this DNS server. So what DNS server will return me back is a list of IP, not a single IP, because I also want to distribute my load. Okay, so I'll just return first IP, IP1, IP2, and then 3, then 4, right? And whenever how DNS do is like they rotate it actually. Whenever they are like next connection is when next client actually gets that request, or next client is making a request to DNS server. So let's say first client they will send 1, 2, 3, 4 IP. For the next client they will send IP 2, 3, 4, and then 1. So they will keep on rotating. And what clients are by default asked to do is like connect with the first IP that you get in the list. So when I get IP 1, 2, 3, 4, I'll connect with IP 1. Right? Some client might get IP 2, IP 3, then IP 4, and then IP 4. So basically they keep on rotating this set of IPs, so that they can keep on load balance it. Okay. And some may ask like, I've seen like directly makes a request to some websites. So what browsers and your device do is like they keep on caching this information for some time. Okay. So whenever they'll say for a day, if they have made a request to whatsapp.com, they will keep the list of IPs throughout the day. And whenever this cache is expired, they again make a call to DNS. That's how at DNS level things are distributed. That's one. Okay. Second is I'm just talking about load distribution. There are other ways of also load distributing. I think people might have used a load balancer, right? So first of all, you have to maintain a connection, obviously, that is HTTP. Okay. So once you have received the IP, that IP is actually these set of IPs are your load balancer IPs, or the first IPs you can connect to. Okay. So these set of IPs belong to your load balancer. So when you get that load balancer, you make a HTTP call. It will redirect you to some service. So how load balancers work? So let's say you have a load balancer, and then you have multiple servers behind the scene. So it will keep on checking the health of these servers. only sends out request to the healthy ones, and the clients basically connect with load balancer. So they will make a request to load balancer for HTTP. Then load balancer will figure out what's the next available healthy host for load balancing. So it will make a connection with this. Let's say this is host 1. Okay, and this basically will keep on just through the load balancer. It will keep connecting with the host 1. Okay, that's how you get this request. And sometimes the load balancers, some application deliberately keep very good boxes. Okay, so that like, let's say HTTP are short-lived, right? They can be easily load balanced. But when you come to WebSocket are I would say connections which are maintained throughout, right? Unless like there's a connection and everything happens. So basically your gateways are your load balancer, sort of, you can assume. So load balancer, and what the only single responsibility they handle is keeping your connections alive. That's all they actually do. So yeah, we have already seen like DNS level load balancing. Then what exactly load balancing does? There's also a concept called redirect. Okay. So redirect, what happens? Let's say you try to connect with gateway 1. Gateway 1 will say that, I'm actually busy. Go check with DNS. What's the next available load balancer? So what gateway this client 1 A will do is again connect with some DNS server. So let's say there's a DNS server, and it will again keep on checking what's the next available, right? And it also maintains the cache behind the scene, so it already knows like what different options I have. But yeah, these applications keep enough number of load balancers so that they can distribute the load. Otherwise, clients will keep on reconnecting or disconnecting. Sort of.
Got it. So basically, gateways are load balancers in the WebSocket world, right?
Yeah.
And of course, we just now saw in the demo as well. So one gateway is managing multiple clients, right? We'll be holding. Okay. Yes. Awesome. Thank you.
So this is the copy each gateway actually have. It knows that which different connection over which WebSocket connections. There could be, let's say, A', some other representation, and they will be like connected. So this is the copy which each gateway maintains, and it's established connection across. So let's we talk about gateways and everything. Let's talk about the thing that we want to cover. Basically, how do I pass on this message from gateway 1 to gateway 2? So let me find a different page here. Okay, so I'll just simply take the gateways now. Thank you. Using the above diagram, you can understand how clients are connected. Gateway 1, and then we have gateway 2. Okay. So now somehow this gateway 1 needs to know that how do I send this information back to gateway 2, so that the request text that I have received from client A, I can send it out to client B. So every gateway has its own copy, but somehow I need to aggregate it. Otherwise, nobody will know that which client is connected to which place. So let's think about a common DB, right? So similarly, they think gateway 1 was maintaining some information and gateway 2 was maintaining some information. What this DB will maintain is aggregation of all this information. Okay. So it basically, let's say this one had A over WebSocket 1, and this one will have B over WebSocket 2. So what this will have is A, and then we have B, then WebSocket connection 1 and WebSocket connection 2, right? So if we can maintain this DB, which actually has all the information about all the clients and whether they are connected, what WebSocket connection they are connected with, and also I think one extra information that will be needed here, or maybe I think instead of WebSocket 1, we could actually simply maintain what's the gateway, okay? Because gateway already has this information, like using which connection they are actually, connection ID and everything. So instead of maintaining WebSocket connection, we'll maintain what's the gateway. Okay. So if somehow gateway 1 knows that client B is connected to gateway 2, it can somehow send that information from gateway 1 to gateway 2. Okay. But let's talk about real life scenario, right? Basically, DBs we don't want to keep. So this is actually direct connection to DB. We avoid. So we'll have some sort of server, right? And a microservice, I should say, okay, which maintains this connection with the DB. And gateways basically publish this information to this service. Right? So if I basically, let's say, call this session service. Okay. So one of the concepts that we use in design is that we don't give multiple responsibility to a single component. Right? I'll just quickly cover why we don't do that. So when we look at, I think when you just want to create MVP, I think boxes, traffic, and everything is small. But when we start to get more and more traffic, we also have to scale up accordingly. And things work smoothly when you know that one box, one set of box is only responsible for one thing. Then you can actually do a load testing of that step. You can see that how much time it's actually taking for that single step and how much boxes I need for this step. Otherwise, if you're, let's say, doing multiple operation using the same service, same box, then it's very hard to scale up services in the right. So that's where this whole concept of microservices and federating different responsibility across the board, across different services that came in. So here what gateway is doing is basically simply maintaining connection. That's only responsibility it should hold. Okay. And then SESA service, what responsibility it will hold? That maintaining the SESA. So across gateway, whatever copy I have, I'll just store this into a database, right? And whenever somebody is asking for, let's say somebody comes back, internal services come that, what's the connection? Where should I send this message for client A? It will respond back saying that gateway 1 is the one place where you should send back the information, and gateway 1 will take care of forwarding it to the right client. So that's what the responsibility is, service session service maintaining. Okay. So keeping the active list, you can say active list. Right. So active list is nothing but this, like which client is connected to which gateway, and then response. So if somebody comes back saying that I want to know what the gateway client is connected, I can simply return gateway. So let's recap. Okay. So client A send this message saying that A is the sender, B is the receiver, send is my operation, and text is hello. Right? Gateway 1 got it. And if gateway 1 connects with session service to see what's the gateway for a receiver, that is client B. So it will make a request to session service. It will figure out gateway 2 is actually the right gateway. So what it can do is actually it can send the information directly from gateway 1 to 2. Okay, and gateway 2 will simply forward this information back to client B. Now, at least using this arrangement, your text messages are getting passed between different clients. Okay, and still this is not the best design. I'll walk through what other components we can have. But any questions so far? How we are maintaining this recorded session service? How do we push it? How do we can send this information from one gateway to another? Okay, looks like everybody is clear on this concept. So I'll come back. So we talk about one principle, right? One service or one instance would only handle one in sort of action. What if a gateway dies, right? I think somebody asked this question. So again, it comes to, there are actually multiple ways to ensure that your system is actually resilient, right? So one is your clustering gateway. So you can actually read about it, clustered load balancer and everything. So what it does, basically, it will have a set of boxes, okay? So let's say DNS will only send one IP. Let's say it sent IP1. And that's the external IP of your devices. But internally, you can have multiple IPs mapped to this. This is actually at network level. So let's say there's an IP5, then there'll be an IP6, then there will be IP7, right? So basically, when a client tries to make a connection with gateway 1, which has an IP address of IP1, internally at network level, it can be handled by multiple different IPs, which your transport layer does not know about. This is basically could be a router, okay? Kind of a gateway hosted inside Kubernetes. I think you can say that is one option. Kubernetes actually give you multiple different or say like devices or instances in the same actual boxes. But let's say you can say that the box itself dies, right? So you can deploy Kubernetes across a cluster, and if even one of the boxes die, let's say this box actually dies, you still have IP6 and IP7, and IP1 can still map to one of those IPs. That's how we ensure that there's a resiliency across your system. But let's say, as a worst case scenario, the entire thing dies out, okay? Then what client can do is like client still maintains that different IP list, simply we talked about, right? So whenever you call from a DNS, you get a list of IPs, not just a single IP, okay? So if you are not able to connect with IP1, you will connect with IP2. You'll take the next one. And if you don't have this information cached, you can again make a call to DNS service and figure out what's the list of IPs. So that's how. So one is like distributing the load balancing it across, making sure that load balance is actually happening at network layer also. Okay. And so another connection request client has to send. Correct. Yeah. So WebSocket connections are again, if somehow it dies out, you can restart connection. It's no big issue. You can create a connection again. That's what all the clients actually do. And whenever, let's say maybe this could happen, right? Let's say A is connected to gateway 1, and somehow this connection is dropped. Okay. And whenever it tries to connect again, let's say there's another gateway 3. And this time A got connected to gateway 3, right? So what will happen is like this session service needs to be updated. So gateway 3 will actually make a call to session service saying that update your records. Now client A is connected with me, right? Gateway 3. So what it will do is will cross out this gateway 1 and put gateway 3 here. Okay. So once A has basically reconnected with gateway 3, all in its information it will send to gateway 3, and gateway 3 will be the responsible for sending back the information to client A, and session service will maintain this information. And if somebody comes back checking like was the gateway connected with client A, it will respond back with gateway 3. Hope that clarifies. All right. So now you have two different gateways. We talked about this, like how we send a message. It will have basically A, B, send, hello. So gateway 1 will receive this, right? And it will basically, maybe it can do some authentication and everything. It will figure out that message is for B. It will make a call to session service to figure out what's the gateway. Then it will figure out that B is connected to gateway B, and then it will pass on this information, right? That send it to B, and the text is hello, and it's sent by A, right? Again, something which is understood across the gateways, right? It's actually an application, and application is written by developer. Developers can actually define the protocol in a way that. Okay. So when this information comes to gateway 2 will send back the information to client B. So client B will get that this information is coming from A, and hello is my text that I have got, and maybe some extra information like timestamp, right? And whatever maybe let's say you want to cover. So that's we can see how we model a message and how do we store it. So that's at a high level. Things we have covered is like how do we send a text message from one place to another. So let me just look at the MVP what we try to go. Okay. Then one-to-one text messaging we covered, single tick, double tick, and blue tick. So before I move to single tick, double tick, and blue tick, some people might actually also ask this question, right? Let's say B is offline. What do we do? Okay. So when we have, let's say you have somehow uninstalled B, or you don't have network connection, you still get your messages when you open the WhatsApp, right? So what there we can do is like decouple this operation entirely, so that gateway 1 will not be responsible for sending the information to gateway 2. If that is decoupled, then gateway 1 don't have to retry, and it can actually save its resources. It can actually focus on just maintaining the connection it has with different clients, right? And that will be a uniform action. So how will this decoupling look like, right? If I do decouple this message sending operation, so what we can do is, again, we can introduce another microservice. Okay, so what this microservice responsibility will be like, get messages and send messages. Okay. And it will have some storage along with it, because one client may come back after a day, it can come up after a couple of hours, you never know, right? So it needs to have some persistent connection or persistent DB. It's actually, again, application level thing. I'll not go into much detail, but what you can see, like when gateway 1 gets a message that client A has sent it for client B, this is the message, that's all, right? So what gateway 1 earlier was doing, it was sending that client A is connected with me. Then it was calling session service to figure out what client B is connected with, right? And then it was sending back this information to client B using gateway 2. So it will now stop doing the second and third action. So it will stop calling session service for getting a response, and it will stop doing or sending directly to gateway 2. What it will do is like simply pass on a message to here. 1 second. Now, yeah, let's realign this. Okay, so what it will do is like basically send a message to your message sender service, we can call it. So it will pass the same information that A has sent for B, then there's hello message, right? And some extra information that you want to put. So it will basically, what sender will do using this interface, get interface, it will post everything to my DB, right? And now once it has stored in DB, it will have some workers, basically some tasks or some threads, everything that is actually handling, basically getting the information from DB and then making call to session service. So what we can do, like now gateway 1 will not connect with your gateway 2. So what this service will do, I'll just start, right? So now the second step and third step of gateway 1 are removed. It basically directly sending it to my sender service. So what sender service workers will do is like they will figure out with session service, right? They will make a call to session service to figure out which gateway client B is connected to. So it will figure out that it's connected to gateway 2, and then sender can directly send it to second, I think drawing. Okay. So what we'll do is basically make a call to gateway 2 directly. So this is how we have decoupled. So instead of gateway 1 directly sending to gateway 2, we are introducing another service which is called sender service. It will get all the information from different gateways. So gateways will do like basically now at a high level, what they are doing is basically maintaining the list of connection. Whatever they are getting over those connections, send it to sender, right? Nothing else, right? And whatever connection status they have, they will send it to session service. So that session service can maintain a centralized place where everybody or other services can check which gateway a client is connected to. Okay. And once details are sent to sender service will have some threads, processor, and everything. to send it out to the right gateway to the receiver end. That's how we pass on a text message from one client to another. Okay. And now gateway responsibility only be to maintain those connection, get a message, forward it to sender. Whenever sender sends back a message to gateway, gateway will basically forward it to client. That's all it will do. So now if you see, gateway will have a sort of homogeneous action, maintaining connection and transferring the data. That's all it will do. It will not look into the data. It will not try to figure out which gateway other gateway is connected to, and all these things will be offloaded to sender. I think this got a bit jumbled up, but I hope folks actually understood this. Any questions on how?
I have one question. Like, if we have introduced the center service, like we have introduced it in the case that there is no WebSocket connection between B and the gateway.
Yes.
Like there is no WebSocket. Okay, so
even B is connected to your gateway too. Sorry, go ahead. Yes,
no, like that is my point. Like if B has no WebSocket connection, that means it is not connected to any gateway, right?
Right. So what will happen?
So there is no entry.
Right. Session service will not have any entry for it. Correct?
Yeah.
So it will basically store this information, this message in a backlog or some DB. That's all it will do. Until and unless that B is connected via the WebSocket, it will not retry sending those messages. So it will just keep the
So
message.
like the sender service will be hitting session service continuously for that.
I think it's again your, I would say, a call. I think you can maybe make it event based, right? Or you can always keep a cache of information. Maybe you can call session service over an interval, right? That's how sender service can actually make its application, right? If you don't want to load the entire network, so maybe you can actually, maybe sign up, subscribe to a stream at session service. Session service can publish whatever changes that are happening to it, right? Or sender service can actually connect over a certain interval. Let's say at this moment B is connected to gateway 2. It tried to send the message to gateway 2, but gateway 2 failed in sending because somehow connection was broken. Okay. So what it will send it back, I think some response it can send back to sender service that the message was not resent, right? Or sent to client B. So it will not delete this message. It will just keep it in the queue, or what it can do is like a certain interval, it can pull to the server session service to figure out if B is coming up online or not. If not, then it will just keep it. It will not send it to the next. As soon as B comes up, it will actually figure out what's the gateway it's connected to, and it will send this sender service will send that information to that gateway, and that gateway will forward it to the client.
Okay, got it.
And I think we can definitely do multiple optimization, how servers, sender service and Zoom service are connecting. But I'm not going to go into much detail at this point. But I think you can always use best practices, caching, different way of polling social service, right? Event-based mechanisms. Those all can be added.
Got it.
All right. Okay, now we'll come to single tick, a double tick, and blue tick. Okay, so I think this can easily cover, as this is not going to take much time. All right, so now let's use the same diagram. All right, and how do we send it? So if you remember, I think I had defined this action actually, just in case for our use case. So when I was defining this, I defined an action called send. That was actually deliberately I had introduced this. So let's say if you have to define another sub-protocol, something for delivery mechanisms, right? Let's say somehow you want to see whether a message was sent actually to over to WebSocket, whether it got received, or whether it got actually whether this message was seen by client, right? So we'll just take the same example. Client A is actually sending to client B. This is the message A to B, then send, then hello, right? So what it has to do, as soon as client A is actually communicating with gateway 1, and as soon as gateway 1 is able to communicate to the sender service, right? So as soon as it's able to communicate to sender service, gateway 1 can actually send a message back to client A saying that this message is sent. Basically, that is single tick, right? So how we can define the protocol for it? Again, you can say that maybe sender. You don't have to keep senders and everything. We can basically simply put it a single text message that basically, let's say, delivery sort of. We can. That's how you can define your sub protocol. Instead of send, you'll say that it's called for delivery, and you can say that it's sent. You can define it anything. Okay, I'm not. It's basically, again, it's a net. You already have a WebSocket connection. You can use that any way you see it. So you can send a message called send. So what your WhatsApp app does is, like, as soon as gateway 1 responses back saying that I have queued it, I got your message. So this is your basically your message was this, and I have sent it to sender service. So somehow I have received your message. That's all it needs to communicate to the client. So it will define some message or message over the WebSocket, and it will send it over the same WebSocket, saying that there's a delivery sub protocol I have defined using this string, and the message is it's been sent. Okay. So when your application or app gets that message, it will put a single tick against your message. That's how your single tick is covered here. Right? Single tick is done. Any questions on the single tick? Right? Single tick is basically, I have received your message. That's all WhatsApp server is saying. Right? Now, how double tick comes in the picture. So when sender has received it, sender figure out that B is connected to gateway 2, right? And gateway 2 sends it back to client B. So now it has been transmitted to B. Okay. So once the gateway 2 know that I have successfully sent it to B, what gateway 2 can do is again send a message to sender service saying that send a message from B to A saying that I have received it. Right? Some again, like, you can define a format. I'm just putting in a cell. I have received. Simply you can see that in text. So the reason I'm keeping everything in text, because we are over a WebSocket connection. We don't have HTTP method and everything, those flexibility. That's, I think, one of the you can say a drawback, but it's again, like, it also gives the flexibility how you can define your internal protocols. So what gateway 2 is doing, it's sending a message to sender saying that forward this message from B to A, saying that I have received this message. But I think I will come to how do we identify that specific message, right? But at least for now, let's assume that there's a single message. Gateway 2 has sent it to sender. Then sender will figure out that what's the gateway A is connected to, right? So it will figure out using the session service that A is connected to gateway 1. So it will forward this received message to gateway 1. Then gateway 1 will forward this received message to then client A. So client A will receive this message that I have received this message, which says that B received this message, right? Receive message or whatever response of hello that you get. So earlier it was single tick, now it will be double tick. Okay. That's the mechanism. Basically, your entire WhatsApp web server is actually telling you that I have got received the information from client B. Any questions so far? All right. So coming to blue tick. Blue tick, I think you guys must have already figured it out. It's again the same way. This at this place, what gateway 2 was doing is, like, gateway 2 was okay. So this received message was actually started by gateway 2. Are you able to see my screen? I think I'm getting some network issues. Can somebody confirm?
Able to see. Can you write something?
Okay.
Yeah.
It's
Yes.
coming, right? Okay.
Yeah.
All right. So what we saw in double tick, that gateway 2 is starting a message, because gateway 2 in sync can identify whether I have transmitted to B or not, right? Because it's over a connection. But now we have to figure out blue ticks. Blue tick is basically when the client B has figured out, basically has seen the message, right? That's where this client B application will start a message saying that I have read it, right? So instead of receive, what we can do is like we can pass on read. Okay. So when client B actually sends it to gateway 2, gateway 2 will send it to sender, sender will send it to gateway 1, and then finally A will receive it, and that is where it will make, instead of double tick, it will make blue ticks. Okay, that's where how your single tick, double tick, and blue tick is covered. So Puneet has asked question, in programming, how do we implement this single tick, double tick? Is there any specific thing? So there's no specific thing, right? Like in WebSocket, you establish a connection, right? Next, everything is as per your programming. Here, I think what you need to, at least minimum information you have to maintain: who is the sender, right? Who is the receiver, and what's the message? And it should be in a way which everybody in the entire network understands. Your client application should also understand, basically your WhatsApp web or WhatsApp Android app, iOS app. The gateway should also understand, your sender should also understand. Okay, but it should be a protocol, something which everybody understands, and you can define it anyway. It could is again, the entire thing is a string. You can maybe split it using comma, you can split it using stars, you can use split it using dollars, anything you can define. Okay. So that's all. We basically, over a connection, you can only send a single string, common string. That's all. So you can format it any way you want. That's so that, but at least you have to communicate or whatever information you need to. So client A should know that who is the sender for it, what's the response, right? And everything will be taken care by using that format. Your app will understand that. Your app will understand that who has sent this information, what exactly I can use this information for. Right. I think Ranjit has mentioned architecture and the codes would complement each other. Right. So your code and everything should understand how exactly what information is needed at what place, and that information should be passed on in a string format over the TCP connections. And TCP connection is just this. TCP or WebSocket connection is just between B and gateways, right? Clients and gateways. Rest everything could be anything. It could be HTTP, it could be over a message broker or anything, or a simple API call, right? It could be anything. The gateways are only maintaining a WebSocket connection over TCP using the client. That's only WebSocket. Any other communication could be HTTP, could be API call, could be message broker, anything. That's your internal service. So everything else is behind the cloud. Your clients are directly only connected with the gateways, and that's the only WebSocket connection. Okay, so we covered single tick, double tick. I think we are over the time. Anil, can we proceed, or should we stop at this point?
Yeah, I think we can stop here.